Alright, very first thing you can do with this video on graphing rational functions is take down the guidelines, the 5 guidelines right now. We've pretty much gone over, I guess the first day you kind of had an explore activity, put a bunch of these functions on your graphing calculator, and you wanted to see the connection with the equation and the VA and the HA. You can see those are the first 2 steps. Always, 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 you want to find the vertical asymptote and the horizontal asymptote first. Then after that, we want to find some other key points. We want to find the intercepts, so x and y intercepts. Remember, to find the y-intercept, you let x equal 0. To find the x-intercept, you let y equal 0. Okay, then step 4, I have plot additional points in all regions. What I mean by that regions, what really affects the regions are the VAs. For example, I'll give you an example. Let's say this is our coordinate plane. Let's say right here you get a VA. You really have 2 regions. This is 1 and this is 2. If you have, let's say, 2 VAs, I'm going to draw another VA. Now you have 3 regions. We'll say this is 1, this is 2, and this is 3 right here. So we have to make sure we have at least 1 point in all those regions. And then I would say once you get done step 4, then you can use your graphing calculator, because some of these are kind of goofy shapes. I wouldn't ask you to just keep plotting points until you get the shape. The main thing I want you to be able to do is get all the asymptotes, the intercepts, and plot additional points. Then at the end you can figure out if it's even, odd, or neither. Okay, even, it's symmetric to the y-axis, and odd, it's symmetric to the origin. A lot of these turn out being neither. Alright, there's 4 on here for this I guess you could say section 2.6-2. We're going to do number 1 and 3. And you'll see, like, the very last thing we'll do is actually graph. So let's do number 1. Let's make this a little bit bigger. There we go. Alright. Okay, let's figure out the VAs. Okay, VA, we just set the bottom equal to 0. So our VA is x equals 2. Our HA, right? Remember, this is where we filled out the chart. The degree is bigger in the bottom, so automatically, if the degree is bigger in the bottom, it's y equals 0. And I'm going to graph those. So I have x equals 2 is right here. And then I have y equals 0, which is just the x-axis, which is this right here. So I have 2 regions. Okay, let's find our x-intercept. To find our x-intercept, we want to set y equal to 0, which is really f of x. So if I have 0 equals 1 over x minus 2. Now here's the one little tricky thing with the x-intercept. When you set this fraction equal to 0, this isn't going to be 2, because that's where I get a VA. The top has to be equal to 0. Well, if you look, I really don't even care about this x minus 2. I can get rid of it. If I have 0 equals 1, well, that never changes. So what that tells me is that there's no x-intercept. That top, the numerator, can never equal 0. So I'll just put NA. No x-intercept. Okay, y-intercept, I'm just going to set all the x's equal to 0. So for the y-intercept, I'm going to have 1 over 0 minus 2. And that's going to give me negative 1/2. So I'll put this in ordered pair form. This is 0, negative 1/2. Okay, so let's plot that. 0, negative 1/2 is like right here. Right there. Kind of tough to do that in between. And a lot of these graphs, you'll see when you put this on your TI Nspire, they're the boomerang shapes. They're just shifted around. All right, now I have here additional points. Well, I have a point in this region. I'll say this is region 1. I want a point in this region, region 2. So I just go to the right of the VA, which I have is what, 3. And I'm going to plug 3 into this. I'm going to plug 3 into it. So when I plug 3 into this, it's 1 over 3 minus 2. Well, that gives me 1 over 1. So this ordered pair is 3, 1. So I'm going to plot that 3 1s right up here. Now at this point, now you put in your graphing calculator, put in 1 over x minus 2. And when you put that in your TI Nspire, make sure this x minus 2, put this in parentheses right here. Very, very important. Sometimes if you don't, you get something that's way off. And then if you graph this right here, you're just going to get the boomerangs. Right? When you have it on your TI Nspire, then you're like, all right, this is top right. Whoops. and this is bottom left here. And that's your graph. So you can see, I don't ask you really to plot a whole lot of points because I allow you to use the TI Nspire to get the general shape. But everything else is real important. Everything that we filled in, VA, HA, the intercepts, and any additional points. And then if I look at this one right here, I mean, I should be able to see this is not symmetric to the y-axis, nor is it symmetric to the origin. This is going to be neither. And if you wanted to check it, okay, we already plugged this point in, 3, 1. I'm going to plug in -3. Right? I plug in the opposites. If I plug in -3, I have 1 over -3 minus 2, and that gives me -1/5. All right, this is completely different from the 1. Remember, if I would have gotten +1 here, it would have been even. If I would have gotten -1 here, it would have been odd. But it's completely different, so it's neither. All right, let's do number 3. Let's jump to number 3. Okay, number 3, again, let's make this a little bit bigger here for you. So let's focus on 3. All right. Okay, the VA, I set the bottom equal to 0. Now, it's not as apparent to see what it is, but it's a quadratic in the bottom. I'm going to factor this up here. So I set this quadratic equal to 0. So x squared minus x minus 2 equals 0. And this is going to factor to x minus 2, x plus 1. So then I get 2 VAs for this. I'm going to get 2, and I'm going to get -1. So let's put that. Make sure we put x. Don't just put 2 and -1. So x equals 2 and x equals -1. So let's graph that. 2, x equals 2 is this. And x equals -1 is this. So now I have 3 regions here. So I have to have at least 1 point in each of those 3 regions. So I could say this. This is region 1. This is region 2. This is region 3. Okay, HA, again, the bottom is bigger. So we get y equals 0. Okay, so y equals 0 again. Again, that's the x-axis right there. Okay, the x-intercept, remember I set y equal to 0, and I just care about the top. So if I make this f of x equal to 0, remember I only care about this top. So really it's like setting x equal to 0. So therefore your x-intercept is just the origin, 0, 0. Okay, the y-intercept, remember the y-intercept, I let all the x's equal 0. So if I do that, I have 0 over 0 squared minus 0 minus 2. This would just give you 0 over -2, and that's just 0. And that makes sense because it gives you the same point, 0, 0. So when we get one intercept, this is at the origin right here. So I'm going to plot this. Now for this one, we have a little bit more work to do. I have a point in region 2, so I'm going to cross region 2 out, but I need a point in region 3 and another point in region 1 for these additional points. So let's just go, so if I use the arrow, like, here's the VA, let's just go 1 to the left. So I'm going to plug in -2 for x. So when I, excuse me, when I plug in -2 for x, I'm going to have -2, and you can even put this in your table for the TI Nspire. Then it's what? -2 squared. Right, it's -2 squared minus -2, and then minus 2. Let's see here. This is going to give me -2 over. This is going to be 4 plus 2 minus 2. These cancel, so it's 4. So this is -1/2. So there's an additional point. I'll put this -2, -1/2. So I'm going to plot that, -2, -1/2, right down here. Right there, if you can see it. Okay, and then let's plug, use the arrow again. I got region 1, that's done with. I have to get region 3. So I'm just going to go 1 to the right here. I'm going to plug in, was it 1, 2? I'm going to plug in x equals 3. Alright, so if I plug in x equals 3, let's see if I can erase any of this. I don't think I can. No, I can't. Alright, if I plug in x equals 3, I'm going to squeeze this in right here. When I plug in x equals 3, I'm going to have 3 over 3 squared minus 3 minus 2. So let's see here, this is going to be 3 over 9 minus 3 minus 2, 6 minus 2. This is going to give me 3/4. 9 minus 3 is 6, 6 minus 2 is 4, right. So this point here is 3 3/4. So I'll squeeze this in right here, 3 3/4. So So it just gets a little ugly with the fractions. Really, the only math or calculations that you have to do is for those additional points. So 3 3/4, it's here, 1, 2, 3, 3/4, it's like right about here. Okay, just estimating. Then we've covered all of these. I have regions in 1, 2, and 3. So then at this point you can graph it on your TI Nspire. And when you graph it, off to the sides you're going to get a boomerang here. Top right is going to be a boomerang. And then in the middle, this is where you get an S shape that goes down left to right. It looks like this. Now you really would have no idea how to know this unless I asked you to plot like 5 or 6 more points. But you just rely on your graphing calculator to give you that shape. A lot of times you can see where the boomerangs are going to be, but sometimes in the middle you make it a parabola or an S shape. That, just rely on your TI Nspire for that. Okay, so if you pretty much just follow the setup, get all the asymptotes, get all the intercepts first, that'll really give you a very good picture of what it's going to look like. To finish it up, use your TI Nspire, but make sure you show all your work here. And then the one last thing, this would also be neither. It's not symmetric to the y-axis, nor is it symmetric to the origin. All right, so tomorrow in class we'll do 2 and 4. I think those are examples where the degree of the top and the bottom are the same. But hopefully this gives you a good practice and a good idea and a good routine to set up of how to graph these rational functions.